Hello everyone, I'm Bingjo. Welcome back to another video. So in this video, this will be the last video for chapter 5, and we're going to be looking at surface area for a lot of different 3D models. Alright, so just going to list down what shapes that we are going to look at. So surface area for number 1, the cuboid. Then we will look at prism, then cylinder, and quite a little bit more. Number 5, we're going to look at pyramid. 6 is cone, and 7 is sphere. Do I still have space down there? Alright, okay, and then I'll write the hemisphere here. Alright, so there are quite a lot of things to cover in this video. We have a total of 8 shapes to cover about their surface area. So first thing first, what is a surface area? So just as the name itself suggests, it's the area of a 3D model. So the area of the faces of the 3D models, all right, it's just the surface area, all right. It's very hard to explain just like that, but we're gonna look at our first example. It's the cube, all right. So if we are to draw a cube, okay, if we are to draw a cube right now, let's draw it with this color right here. Okay, so if I'm gonna draw a cube, okay, so this is the cube. All right, so if you are gonna lay it out in the net diagram, I'm not sure if it's called net diagram, it will look something like 1, 2, 3, 4, 5, 6. Yeah, I'm pretty sure you have learned that before in somewhere before this. But yeah, so the surface area technically means to calculate each of this area A, B, C, D, E, and F. All right, because when you fold it up, then it's like the outer area here. This is one area, and this is another area, and this is another area. And from the back part, we have that part over there is the area, and that part over there, and the bottom one. All right, so there are a total of 6 surfaces in this cube right here. So we are to calculate the surface area, which is the total area of each of the surface in this cube. All right, hope if I word it out like this, it makes more sense. So we now say that this cube has a side of x. All right, so we know that for a cube, it's basically a square but in 3D, right? So each and every single the base, the width, and the height is all x. All right, the length is all x. So first we're gonna calculate the area here. So area of one side is equals to x squared. All right, it's just the base times the height. So we know that since a square has the same length and the cube is technically built out of squares, right? So we know that there are 6 surfaces in the cube made out of squares. Therefore, we can jump straight to the conclusion that the surface area, all right, I'm just going to write the whole word here, surface area of cube will be equals to 6x squared. All right, and remember, this is area, so it will be in terms of unit square, not cube, yeah, because it's not volume. All right, so this is a common misconception of people thinking surface area is like a volume, but it's not. All right, volume is whatever is contained inside this 3D model. All right, so it will be x cubed instead because it's the base times the width times the height. All right, but the surface area is just to calculate the surface of the model. All right, so we're gonna jump to the second one here, which is a cuboid. So what is a cuboid? Right, it just sounds like a cube, is it? So cuboid is basically the rectangle version, the 3D version of a rectangle. All right, so it goes something like this. So you're gonna draw a rectangle, and you're gonna extend it to a 3D model. All right, it's basically just like that. Okay, so it can work out as x, y, and z. All right, so that let's say all the sides are different, then it is a cuboid. All right, or you can have something like this two part is the same. All right, while or you can have something like this. This is x, this is y, and this is y. All right, these two is the same. All right, it can happen too. Right, so in this part here, we're just gonna look at this x, y, z here. So in this case, if we are gonna lay it out in these terms, all right, we have 1, 2, 3, 4, and 5. Okay, so we know that this long part is x. All right, and then this connecting here, this is z. All right, and this is y. All right, so it's a little bit hard to lay it out like that because I'm not that good in this diagram. So in short terms, we're just going to calculate every single area that we are going to see here. So the area for this side is area of this. It's still hard to draw. All right, area of the front will be equals to x multiplied with z, so it's xz. All right, and we know that the front will be the same as the back, so we know we need to calculate it twice when we go to the final line. All right, so the area of the left side, all right, the left side is this part right here, will be equals to base times the height, so it's yz. All right, and last but not least, the area of top. All right, so the top and the bottom will have the same one because they build up as a 3D model. So it's x multiplied with y, so it's xy. All right, so the surface area of, it's just ugly. Wait, surface area of a cuboid will be equals to 2 multiplied with xz plus yz plus xy. Right, it's just that simple. So remember to multiply each of these 2 times because you must remember the area of the front will be equals to the area of the back. All right, because in the front here you see x multiplied with z, and the back part here, this is z and this is x also. So you get 2 same area, so the surface area of a whole cuboid will be equals to 2xz plus 2yz plus 2xy, and after we factorize it, we get this last line right here. All right, so this is how we get the surface area of a cuboid. All right, so next we are gonna look at the prism. All right, so number 3 is the prism. So what is a prism? A prism is basically the 2 ends are the same shape, and then you're gonna make it a 3D one. So we can have a triangular prism, all right, which looks like a tent. Wait a second. Which looks like a tent, or you can have like a pentagon prism, right? It can happen too, okay? Something like this and dotted line, anything, as well as both ends are the same. All right, so in this case, we're just gonna look at I shouldn't have rubbed that actually. This is a beautiful one. So in this case, we're just gonna look at this. Let's name it equilateral. All right, so we're gonna name this the equilateral triangle prism for just too easy to show. All right, okay, like this. Great, and they have x here, and then this is y, and then we will have the height here. Okay, so surface area of a prism. We are still gonna break it down to every single area that we can get. So the first thing, we're gonna look at these 2 identical triangles here. So area of triangle will be equals to 1 over 2 x multiplied with h. All right, it's just half base times height. Then the area of the slanted part will be equals to, since this is x and this is y, it will just be a slanted rectangle. All right, so if you're gonna make it straight, it's basically something like this. All right, yeah, it's just something like this, but you fix it, you make it slanted to make it like a prism. All right, so this will be equals to just x multiplied with y. All right, and take note, this is the same as the one at the back, and it's the same as the one at the bottom. All right, so the surface area of an equilateral triangle prism. This is very important because if it's not equilateral, meaning this can be a Z and maybe this is A, so it's like a different length, then it will not be as easy as just calculating 2, because this will be different than the one at the back and the bottom one will be different also. All right, so the surface area in this case will be equals to, all right, we have two triangles, so it's 2 multiplied with half x times h, plus you have three faces, three rectangle faces. All right, so it's 3xy. And after you do everything, it's xh plus 3xy. All right, you don't need to memorize this formula. You just need to know how to calculate a surface area. Then you can derive it just by looking at the shape. Because sometimes they might give you some weird shapes that are a combination of different 2D shapes that we know the area. Let's say they combine a triangle with a, let's say, with a hexagon, or they combine it with a trapezium and some stuff. So you need to know the area of each of them and add them together. So the one hard part of surface area is sometimes you are just gonna ignore one part. So let's say you just know that, oh, there are two triangle faces, so you multiply the area of triangle with 2. That's correct. But when you go on to the slanted faces, you just multiply with 2 because you forgot there's one more faces at the bottom. So that's the common mistake that a lot of people will make. So this is one thing that you need to take note when you calculate surface area. All right, so the fourth one we're going to look at is a cylinder. All right, so cylinder is a shape something like this. Okay, let's write down 4. Cylinder. All right, so cylinder is something like this. Okay. Okay, so how do we calculate the surface area for this? Okay, the first thing, we know that there are two circles. Usually it will be circle, it will not be oval, because we don't actually learn area of oval shapes here. So this cylinder is made out of the circle right here with R. All right, so from the previous video, we know that, and when you are in touch with all the circle stuff, you must take note of the pi. All right, so you must think of the pi. So first thing, we're just going to look at area of the circle, which is equals to pi r squared. All right, it's just pi r squared. But how do you calculate the area in this middle? All right, so sometimes our teacher last time would just tell us to remember, and then because the derivative is actually very complicated, but I'll try to make it as simple as possible so that you memorize it with sense, right? So it makes sense to you. So as you can see, this middle part is attached with the circle. All right, so if we are to break this cylinder and open it up, all right, so you will get something like this. All right, just imagine this paper right here. All right, and you are just gonna turn it so that it looks like a cylinder, right? So this length right here is actually the circumference of the circle, right? Do you see it? This is the circle, all right? And this is the circumference of the circle. So when we break it out, this whole thing is actually the circumference of the circle, right? So this will be, the circumference of the circle is 2 pi r, right? So it actually makes sense. And this is the height given, so it's just h. All right, so this is gonna be h. Okay, so after you know this, so the area, all right, let's change back to the color. Area of this thing right here is actually 2 pi r multiplied with h, right? It's actually just that. So the surface area of cylinder is just 2 pi r square plus 2 pi r height. So you might actually wonder when your teacher just tell you this formula, all right? How do you get the 2 pi r height? And sometimes they will just ask you to just memorize it, all right? It will make your life easier if you understand how do you get this 2 pi r height from. So you don't need to deadly memorize this formula, you can just derive it, right? So this is the fun of the math. You don't need to memorize a lot of formulas actually. So this is how you get the surface area of a cylinder, 2 pi r squared plus 2 pi r height. Okay, so the next thing here we're gonna look at is, let me scroll back to my pyramid. All right, so basically there are a lot of different types of pyramid. Okay, how many slides do I still have? I actually have a lot. So pyramid. 5. Pyramid. All right, so to draw a simple pyramid, it will be something like this. Okay, never mind. Let's draw the base of the pyramid first. Then we have everything going up to the center. All right, so a pyramid is basically just like that. So if you have a equilateral pyramid, if you have a pyramid made out of equilateral triangles and squares, then the examiner is probably just kind-hearted, right? So let's say this is x, this is x, this is x, and this is x, and so on. So all the length here is x. All you need to do is to break it out into, this is the triangle with length x, and the base down there is a square. All right, it's a square with length x. So the area of the triangle, all right, will be just equals to, you find the height using the trigonometry rules. I really think that trigonometry should be really in front. Okay, it will be here in 3 videos time. All right, so the area of the triangle will be equals to 1 over 2 base times height. And the area of this base down here is equals to x squared. So a pyramid is made out of 4 faces, as you can see from there. Don't know if you have seen a pyramid in your real life or any movies. It's just basically like a mountain, but 4 triangles covering down. So the surface area of a pyramid will be equals to 4 triangles, so it's 2xh plus x squared. All right, you need to take note that this formula don't always hold if this is not an equilateral pyramid. All right, so let's say this is isosceles, so it's xx, but down here is y. So your your area of triangle will be 1 over 2 y times h, and the area of the base will be y squared instead, right? And your h will depend on x and so on. So please do not memorize this kind of formula. Derive it from the shape that you get. Okay. So after pyramids, we're gonna look at how many space do I have here? Still very less actually. We are gonna look at cone. Okay, cone. This is interesting. The formula is interesting. I remember when I memorized this during my high school time. So cone is something like an ice cream cone, but we're gonna look at it like this. I prefer to draw it like that instead I prefer to draw it like a party hat instead of an ice cream cone. All right. So down here is a circle. All right. Assume it's a circle because it's a 3D model, but usually it's a circle. It's R. All right, and this slanted height right here is L. All right, so the surface area will be just the summation of area of the circle at the bottom, pi r square. All right, but the area of this slanted part right here, if you're going to break it out, all right, not sure if in your science, when you have your lab experiments, your teacher will give you like a circle, something like that, okay, but you are gonna fold it into cone, right? So you're gonna fold it into cone-like structure, all right? So however, this is not how the formula, it's kind of related, but it's not. So the area of this slanted part right here will be equals to pi r l. All right, I have to apologize for not being able to give you the exact reason why it's pi r l. But if I'm gonna say it, because the structure of this cone, I'm not sure if I can do it right here. You need to kind of turn it in terms of like this, right? So it looks like a cone, right? So it's very hard to actually visualize this. However, if you are to just memorize it, then it will be surface area of cone is equals to pi r square plus pi r l. All right, it's just that it's just that formula right there. Okay, and after that, pi r l, remember this l is the slanted height. So usually in the questions, they might give you this h right here, and they give you this theta. So you need to look for l by using the trigonometry rules to get this pi r square plus pi r l. Okay, so next it will be, after cone, we'll be looking at something called a sphere. Okay, so number 7, we have sphere. So a sphere is just like a ball shaped type, but it's the radius is the equal at all sides. All right, so we draw a sphere something like this, a circle, but with a lot of dot 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 dot. It's like a globe, right? So this is a sphere. And then we have the radius r. So a sphere with radius r, uh, no derivation, surface area is just 4 pi r square. I can't explain this. I tried to Google it. I don't understand. So just memorize it, 4 pi r square. But if I'm not mistaken, sometimes in exam, they might give you this surface area, the formula of the surface area of a sphere. But if they don't, just in case, just memorize it. All right, and something worth to actually state here, the volume of a sphere is equals to 4 over 3 pi r cubed. Same thing, no derivation, I don't understand, but it's just something to memorize. Yeah, I can't believe I actually said that, but yeah, sometimes you just have to memorize stuff, isn't it? So after sphere, we have hemisphere. Hemisphere is basically a semi-sphere, right? Like the circle, we have a semicircle. So hemisphere is basically a sphere cut into half, all right? However, the tricky part is the surface area is not cut into half, all right? Because the surface area of a sphere is 4 pi r squared. When you cut it to half, this part right here is 2 pi r squared, correct? But, all right, there's a but. Surface area will be equals to the 2 pi r squared because you divide this 4 pi r squared by half. But now you have another surface at the bottom, right? So this is something that a lot of people will forget. And this is actually a circle, so it's plus pi r squared. which gives you 3 pi r squared. So this is the surface area of a hemisphere, and you need to take note of that because a lot of people will just write 2 pi r squared, and that's wrong. Okay. And something to mention about the volume, there's no tricks here. It's just literally divide by 2. So it's just 2 over 3 pi r cubed. All right, so yeah, I think with this, uh, it's all about chapter 5 as stated in the syllabus content. And yeah, in this video, we have looked at a lot of surface area of different shapes. And one thing to remind you is that you don't have to memorize any of the formulas except for the sphere and the hemisphere, of course. You just have to derive it sometimes, especially the cuboid, prism, cylinder, and pyramid, because they might give you different conditions where it's not equilateral triangle, it's a isosceles, or it's like a different kind of triangle where there are no equal sides. All right, so yeah, I hope you guys understand how to calculate surface area after watching this video. And yeah, I'm gonna see you guys next time where we're gonna go into chapter 6, where we are finally gonna be looking at trigonometry. All right, thank you very much, hope you guys enjoy.